Have you inherited a database that looks like a plate of spaghetti, no docs, inconsistent names, and you have no idea where to start? I've helped thousands of developers improve their database design skills. And in this video, I'll show you a step-by-step framework to clean up any messy database, so you can finally make sense of it again. By the end, you'll know exactly how to take a chaotic schema and turn it into a clean, maintainable system your team can trust. And if you'd like a checklist version of this framework, grab my database cleanup guide. The link is in the description. Before you change anything, you need to document your current database. Start by exporting the schema, which includes the tables, columns, constraints, indexes, and everything that defines the structure. You can do this manually or use your database's metadata tables. Many SQL editors allow you to export the database objects into SQL files as create statements, so you can open the files to see what they are. Or you can query the data dictionary tables that exist in most databases. For example, in PostgreSQL and other databases, you can query the information schema.columns table to see all of the columns and tables in your database. This query lists all tables and their columns in the database, along with each column's data type. It's written this way because the information schema view is available in most databases, so it works across different systems. Another thing you can do, either using the exported SQL files or your SQL editor, is to generate a database diagram. This is often called reverse engineering, and you can create a diagram from your tables. This can help you visualize the relationships. Highlight problem areas like missing foreign keys, unclear relationships, or inconsistent naming. You should also note any triggers, views, and stored procedures that you see in your searching. You probably won't see them on a diagram like this, but you'll see them in your investigation. A common mistake is skipping documentation because you think you'll clean it later. Without it, you'll break something you didn't know was there. Now that you've started to get some of the database documented, the next step is to analyze how the database is actually being used. You're looking to find out answers to the questions like which tables are still active. Are there columns that are always null? Are there duplicate or inconsistent values? Which queries are slow or run too often? Now, this is probably the hardest part. Depending on your project or application, this could be done in a few different ways. You can ask some people who are more experienced than you with the system. You could look through some of the application code. Or you can look at some of the stored procedures if they are being used. In my current role, we have quite an old database we're working with. There are a couple of people who have been around for a while who know it pretty well, so my first step whenever I need to understand something is to talk to them. Then I work with the developers to understand the code. The goal of this phase is discovery. You're finding what's wrong before changing anything. The output of this is going to be a list of things that are wrong or could be improved with the database. This could be quite a long list. Once you know what needs improving, it's time to refactor your schema and make the changes. This is where you make structural changes, but safely and incrementally. However, don't go and make all of the changes at once. Start with simple wins. Rename unclear columns. Merge duplicate columns. Add missing constraints or foreign keys. Remove deprecated stored procedures or legacy tables. Traditionally, making database changes has been hard because of the risk of breaking something and the impact to production code. However, improvements in the process and tools have made this easier. Generally, you want to follow a process that means you make small steps to reduce the risk of change. For example, instead of making a large change that renames a column and updates application code, you can do it in stages. Start by adding a new column with the right name. Adjust the application code to read and write from the new column. Perform a data migration to populate the new column. Then, once everything is working, drop the old column. All of these steps would be done in separate releases to reduce the impact on the live system. It may take longer, but it's safer and easier, which is ultimately what the business cares about. As you clean up, keep everything consistent. Normalize or denormalize where appropriate. For example, if a single table holds order and item data together, you can split it into separate tables for orders and order items. Use consistent data types. If you're storing true or false values, use a Boolean column if it's available, or perhaps a tiny integer, instead of a long varchar field. Always test your changes in a staging environment before applying them to production. A good habit is to keep a change log that records every schema update, the reason for it and when it happened. That documentation will save you later when somebody asks why a column was renamed or a constraint was added. One of the pivotal moments in my journey with software and databases is learning about the concept of continuous integration. I was developing an application as a side project, and whenever I needed to deploy a change, I would run an SQL script on the production database directly, and then copy and paste files onto the server using an FTP tool. This is what I learned to do many years ago. And then I wondered, surely there's a better way to do this. Then I found the concept of deployments and continuous integration, which led me to the book Continuous Delivery by Jez Humble and Dave Farley. This book is one of the most impactful books I've ever read, and it blew my mind how software could be delivered. I put into practice what I learned from the book, and after some research, I had a much better deployment process for both my database and my application code. How is this relevant? Well, now that your schema is clean and consistent, it's time to modernize your workflow. This is what I did when I discovered the concept of continuous delivery. This is probably quite a big change, especially if you work in a large organization. However, you can take small steps. The goal is to add automation so you can maintain your database in the future. There are tools like Flyway or Liquibase that help you version control your schema, just like your application code. Each migration script represents one change to the database. It's written this way so each change is applied in order, ensuring every environment stays consistent. You can also add continuous integration checks to automatically test your migrations before deployment. This means no more manual SQL scripts sitting in random folders. Your schema becomes versioned, traceable, and repeatable. If you'd like a downloadable version of this entire process, download my free database cleanup checklist using the link in the description. It includes a checklist you can use on your own cleanup project. Cleaning up a database might seem overwhelming, especially if you have a large database. However, when you follow these steps of document, analyze, refactor, and modernize, it becomes a clear and repeatable process. Start small, keep good notes, and your database will stay organized in the long term. It's possible to deploy a database change without an outage. Watch this video next to learn how to do that, which expands on what we covered in this video. Thanks for watching.